Okay, so this is Algebra 1, Semester 2, second lecture, Chapter 7.3, and Chapter 7.4. So, the first thing they do is talk about multiplying powers of exponents. So they give us an example of uh, x to the fifth power, and they square it. Well, notice that the x to the fifth power is inside a parentheses, and it's being squared, meaning this thing inside the parentheses is being multiplied twice. So it's going to be x to the fifth times x to the fifth. So x to the fifth times x to the fifth. Remember that when you're multiplying exponents like this, and they're not raised to another power outside of parentheses, you add these guys. So that's x to the fifth plus 5, which is x to the 10th. And this happens all the time, so much so that they came up with a rule for it. Instead of expanding it out and adding all the exponents, what you can do is whatever is outside the parentheses multiplies inside the parentheses, and I can say that this is x to the fifth times 2, which gives me x to the 10th. So x to the fifth raised to the second power is the same thing as multiplying the 2 and the 5 to get x to the 10th. And that is what happens when you raise a power to another power. When you raise a power to another power, you multiply the exponents. So the book gives us a couple examples. They give us 5 to the fourth power, and they raise it to the second power. Again, we're just multiplying, so it's going to be 2 times 4, or 5 to the 8th power. So the answer is 5 to the 8th. They give us a to the 3/2 power, and then they multiply it times 3. So again, we're multiplying the fraction, so it's going to be a to the 3/2 times 3 over 1. This gives us a to the 3 times 3 is 9, 9/2. So it's going to be a to the 9/2. Again, we're just multiplying. The exponents. They got m to the third power, and they raise it to the fifth power, and which is m to the 5 times 3, which is m to the 15th. They also give us x to the 1/2 raised to the 3/5 power, which is x to the 1/2 times 3/5, which is x to the 3/10. X to the 3/10. Again, multiplying the exponents when one power is raised to another power. Alright, a couple of examples of this. I'm just going to do 2. I'll do the 2 fraction one since I know everybody loves fractions. So got it, number 1, letter C. They give me p to the 1/2 raised to the 1/4 power. That's going to be p to the 1/2 times the 1/4, which is p to the 1/8. Again, we're just multiplying the fractions in this case. For D, we have also p to the 1/4. Oh, notice what they do here. Raised to the 1/2 power. Here it was 1/2 raised to the 1/4. Here is 1/4 raised to the 1/2. The process is identical. You're still multiplying these two exponents. So it's going to be p to the 1/8. P to the 1/8. Again, we are multiplying the exponents. All right, so they have examples of what happens when you multiply and then one of them is being raised to a certain power. So here we have got it to letter A. This is x squared times 6, x to the 6th power raised to the negative 4th power. So this is sort of order of operations again, PEMDAS. And what you do first is we have multiplication here. We have exponent here. So PEMDAS says that the exponent is first. So we're going to multiply this negative 4 times 6, and it's going to be x squared times x to the negative 24. X squared times x to the negative 24. After you do that, then we multiply them, and now that nothing is being raised to another power, there's no x's within outside with a parentheses to the exponent. This is where we add these two guys together. So you're going to add x squared plus negative 24, x to negative 24, so 2 plus negative 24, and that's going to give me x to the negative 22. Once you get here, remember that it is not simplified if your exponent is raised to a negative power. I repeat, it is not simplified if your exponent is raised to the negative power. So what you're going to do after this is you're going to do the reciprocal. Remember that negative exponent means that it's the reciprocal. So your answer is going to be 1 over x to the 22nd power. And that would be your final answer. So PEMDAS tells me to multiply first, or do the power first. So I multiply negative 4 times 6 to get negative 24. Then I can add the exponents because nothing is being raised to anything. Negative 24 plus 2 is negative 22. Then, since it's a negative exponent, I had to flip it down and put it in the denominator. Remember that once you put it in the denominator, the negative sign goes away, and I get 1 over x to the 22nd power. Got it to B. I have w to the negative 2 times w to the 5/3 raised to the 3rd power. Again, we have multiplication right here. We have w to the 5/3 raised to the power over here. So we're going to multiply the 3 times the 5/3, which gives me w to the negative 2 times 3 times 5/3. The 3's cancel out, which gives me w to the 5th power. Now that nothing is being raised to another power, I can add these guys. So 5 plus negative 2 is 3. So then my final answer would be w to the 3rd power. So again, I multiplied the 3 times the 5/3 because it's raised to another power. The 3's cancel out, which leave me with the 5. So then I have w to the negative 2 plus w to the 5th. I add those two exponents, 5 and negative 2, which gives me positive 3. Okay, so we'll leave that right there. Let's go on to the next example that they have for us. More raising a power to a power. So here, this says that if I have two things in here, so I have 3x. Couple things to note. If there is no power, so I have 3 and x, that's the same thing as saying 3 to the 1st power times x to the 1st power. Sometimes people see it this way with the 1 here. That makes it a little bit easier for them to set this up. They're raising it to the 4th power. So now with that 1 there, it's kind of easier to see that we still get to multiply. There is an exponent here. It's raised to the first power, but we don't consider that simplified. This is simplified over here, and this is not simplified over here. So you're going to multiply the 4 times the 1 over here, and multiply the 4 times the 1 over there, which turns it into 3 to the 4th power times x to the 4th power. 3 times 3 times 3 times 3, I believe that is 81 times 3, and then x to the 4th power. When you have expressions inside the parentheses that are being multiplied or added, or divided, or subtracted, you're going to multiply everything inside that parentheses by whatever the power is. So since there's a 3 and an x, you're going to multiply, or you're going the 4 times the 1. That's going to be raised to the 4th power, and then the 4 is also going to be raised to 3 is also going to be raised to the 4th power. So let's do a couple. This is got it number 3, letter A, which gives me 7m to the 9th times, or rather raised to the 3rd power. Again, there's a 1 here if you want to put a 1 here. It's going to be 3 times 9, 3 times 1, so it's going to be 7 to the 3rd power times m, and this m is going to be 3 times 9, so that's going to be to the 27th power. 7 times 7 times 7 is 343, so our answer is going to be 343 m to the 27th power. And some of you might be asking, well, how come I'm not adding the 3 and the 27? And the reason why I'm not adding the 3 and the 27 is because they're not the same term. This is an m, this is a number. They're not like terms, so I cannot add their power. Let's do B. Alright, so B says we have 2z, and they are both being raised to the negative 4th power. Again, if you want to put the 1 here, you can. I do it all the time. Negative 4 times 1, negative 4 times 1 gives me 2 to the negative 4th power z to the negative 4th power. Again, I can't leave it here because it's not simplified because my exponents are negative. So what I'm going to do is I have to flip it down into the denominator. The 2 goes down, it's raised to the 4th power. Remember that the negative sign goes away. Z to the 4th power, and again the negative sign goes away. And my final answer is going to be 1 over 2 to the 4th. Oops, no it's not. Don't listen to me. I tell lies. 1 over 2 to the 4th power, z to the 4th power. 2 to the 4th power, 2 times 2 is 4, times 2 is 8, times 2 is 16. So it's going to be 1 over 16 z to the 4th power. 1 over 16 times z to the 4th power. Okay. Okay. This is more of the same. The only difference is now there's more variables and more than one thing that's being raised to the power. But the process is exactly the same. It's just going to take a little bit longer, but nothing has actually changed. You're still multiplying if it's raised to another power, and if they're the same variable, then you're going to add their exponents. So for got it number 4, letter A, we have x to the negative 2 raised to the 2nd power times 3xy, and the y is raised to the 5th power. All of that is being raised to the 4th power. So I can multiply this 2 times this negative 2 to give me x to the negative 2 power. This 4 is going to multiply the 5, this 4 is going to multiply the 1, this 4 is going to multiply the 1. So that's times 3 to the 4th power times x to the 4th power times y, 4 times 5 is 20, to the 20th power. Remember that there's a 1 here if you want to put it there if it makes you see it better. Okay. So I'm going to move some things around. In algebra, we like our constants to be in the front. So I'm going to put 3 to the 4th to the front. I'm going to put the x's next to each other. So x to the 4th times x to the negative 2. And then I'm just going to leave that y in the back. Okay. 3 to the 4th, 3 times 3 times 3 times 3 is 81. Since these are since both of these have the same variable, they're both x, I can add these guys. So it's 4x plus negative 2. 4 plus negative 2 is 2, so x squared. There is no other y's to add this y with or subtract this y with, so I just drop it and leave it alone. And my final answer is 81 x squared y to the 20th power. Again, the process that I did is just like the process we did before. We're just doing more of it. I multiplied the 2 times the negative 2 to get... Oh. Well, look at me. I'm so silly. 2 times negative 2 is not negative 2. 2 times negative 2 is negative 4. Sigh. Alright, so this is not negative 2. This is negative 4. I apologize. So negative 4 plus 4 is to the 0. So let's rewrite this. All of this. Alright, so 81, x to the 0, y to the 20th. Well, we know that anything raised to the 0 power is 1. So this is going to be 1. And then 1 times 81 is just 81. So then our final answer would actually be 81 y to the 20th power. I apologize. I'm glad I caught it. So 2 times 2 is negative 4. 4 times 1 is 3, so that's 3 to the 4th. 4 times 1 is 4, that's x to the 4th. And then 5 times 4 is 20. Everything else checks. But the process is still the same, though. I just messed up on the number. 4 plus negative 4 cancels out, which gives me x to the 0. X to the 0 is 1. So then 81 times 1 is 81. And y to the 20th times y to the 20th is y to the 20th and times 81. So, boom. That is that. B says we have 3 c to the 5 halves, and that's being raised to the, I'm going to put a 1 here, 4 times c squared to the 3rd power. I multiply the 4 times the 1, I multiply the 4 times the 5 halves, so this is going to be 3 to the 4th. Let's see. 5 halves times 4. So 4 divided by 2 is 2. 2 times 5 is 10. So this is going to be c to the 10. Or you can think of it as 20 divided by 2 as well. Then I multiply the 3 times the 2. So that's going to be c times c to the 2 times 3, which is 6. 3 to the 4th power, again, is 81. I guess they like raising 3 to the 4th in these problems. I'm going to add these two guys. So 10 plus 6 is 16. C to the 16. So our answer is 81 c to the 16. Alright. What is the kinetic energy of aircraft with... So I'm not going to... I mean, I could do this and use the whole 1/2 mass times velocity squared and stuff. But that's more of a science type problem. It's more of a physics types problem, really. And you'll see it in physics, so there's really no point. So don't expect that on the test, and I don't really feel the need to go over that. All right, so that is 7-4-3, and now we get started with 7-4. 7-4 deals with division. So if when we multiply variables, x to the 4 times x to the 4, we add them, x to the 4 plus 4, which is x to the 8th, then it's logical to conclude that if we divide exponents, x to the 4 divided by x to the 4, if multiplying and adding are involved up here, division is the opposite of multiplying, then subtraction would be the opposite of addition. So if we're dividing exponents, then we're going to subtract those powers. So when we divide exponents, and remember the bases have to be the same, we subtract their powers. The book gives us a couple of examples, but let's go through them. So we have here y to the 3/4 over y to the 1/2. Same thing as saying y to the 3. By the way, whatever is in the numerator is always going to be the number that's subtracted first. So 3/4 is going to be first, minus y to the 1/2. 3/4, this is not the same denominator, so I got to multiply top and bottom by 2, so this turns into 2/4. 3/4 minus 2/4 is 1/4, so our answer is y to the 1/4. B, we have d to the 7/2 over d to the 3rd, which is d to the 7/2 minus 3. I'm going to write it as 3/1. I will multiply top and bottom times 2, and that would get me 6/2. So 7/2 minus 6/2 gives me d to the 1/2 power. So just to illustrate this point down here, 7/2 minus 3/1. Since their denominators aren't the same, I have to multiply it by a number so that they're both the same. So I choose 2. 2 times 1 is 2. What I do to the bottom, I do to the top. So if I multiply the bottom by 2, then I multiply the top by 2, which turns it into 6/2. So if you're wondering where the 6/2 came from, I had to have a common denominator. Alright, let's do C. K6, J2, K, we're going to put a 1 here, K1, J5. Okay. That's the same thing as saying K to the 6 minus 1, 6 minus 1, and then times J to the 2 minus 5. Now notice I have to do it only with the same base. So K to K, 6 minus 1, J to J, 2 minus 5. That gives me K to the 5 times J to the negative 3. Remember that I can't have a negative exponent for it to be simplified, so that J is going to move down to the denominator. K to the 5 stays where it is. Remember that once I move it down to the denominator, the negative sign goes away. And that is the answer. So I only subtract when the bases are the same. K is to K is J to J. 6 minus 1 is 5. 2 minus 3 is negative 3. And then I have to put that J to the third power in the bottom in order to get rid of its negative sign so it can be considered simplified. Dividing scientific notation. Again, I'm not going to really do that to you guys. I'm not really spending a lot of time with scientific notation, so I'm not going to bother with it here as well. What is these? Okay, when we have a fraction, raising it to the power. If we have a fraction, they call it a quotient. Quotient, fraction, division, they're all the same thing. And we raise it to a certain power. Remember, there's a 1 here and a 1 here if you want to put it. We are going to raise the denominator and the numerator to the same power. So this is going to be 3 times 1, 3 to the third. This is going to be 1 times 3, 5 to the third. So 3, I believe is 27. 5, I think it's 125. 125. And then that would be my answer. That works with variables as well. Remember, there's a 1 here and 1 here if you want to put it. Raised to the 5th power. Boom, boom. So x to the 5th, 5 times 1. Y to the 5th, 5 times 1. And I'm done. Then we have a over b to the 1/2 power. Again, if you want to put a 1 here and here, you can. 1/2 times 1, 1/2 times 1, which gives me a to the 1/2 over b to the 1/2. So when you have a fraction and it's raised to a power, notice that the fraction is inside the parentheses. This only works when the fraction is inside the parentheses. If there is no parentheses, the only thing that's being raised to a power is that numerator. Then you multiply the numerator and the denominator's exponents by each other. Okay, so for a, got it 3a. We have 4 and x to the third. Again, if you want to put a 1 here, you can. Raised to the 2nd power. 2 times 1 is 2. 2 times 3 is 6. 4 times 4 is 16. So it's going to be 16x to the 6. For reasoning number B, I actually like this one. This is pretty good. They say describe 2 ways to simplify this expression. So we have a to the 3/4 over a to the 5th. Actually, let me erase the whole thing and start over. Do it both ways. So B, the first method. And this is actually the method that I would do it in my brain. A to the 3/4 over a to the 5th. And it's being raised to the 4th power. So since both of the variables are a and they're being divided, I can actually subtract what's in the parentheses first and then multiply it by 4 on the outside. So it's the same thing as saying this. A to the 3/4 minus, someone could say 5 over 1 to the 4th power. Because I'm dividing and they're the same base, I subtract their exponents. Then I'm going to subtract this first. I multiply this top and bottom by 4, so this turns into a to the 3/4 minus 20 over 4 raised to the fourth power, which is a to the, so 3 minus 20 is 17 negative. So negative 17 over 4. And I raise that to the fourth power. Now here I multiply, right? I multiply the 4 times the 17 over 4. These guys cancel, which leaves me with a to the negative 17. Again, not simplified. So I bring it down to the bottom, and the negative sign goes away, and I'm done. So this method that I chose to do is subtracted the um, I subtracted the exponents first inside the parentheses. 3/4 minus 5 over 1. I found a common denominator and turned 5 over 1 to 20 over 4, and I subtracted and got negative 17 over 4. Then I multiplied the 4 on the outside times the negative 17 fourths, which caused me negative 17, and then I was able to drop it into the denominator. And remember, once you drop it into the denominator, the negative sign goes away. So that's one way to do it. And the other way to do it is to multiply first and then subtract. So a to the 3/4 over a to the 5 over 4. I can multiply first, and this would be a to the 3 over a to the 20, which gives me a to the 3 minus 20, which is a to the negative 17, which ultimately is 1 over a to the 17. It works with a problem like this when it's sort of where the fractions cancel out, and it's easier that way, but I actually like to subtract my exponents first because most of the time it's not that easy. But they will both get you to the same place, and whatever method makes you happy, go for it. Okay, lastly, multiplying by negative exponents. When we multiply by negative exponents, it's the same exact process. So the book is telling you to do it another way. The book is saying, if I know I'm multiplying by negative exponents, I can flip them and then do it that way. It doesn't really matter when you flip them. And I think that's a little confusing to do the reciprocal and change the sign before you attempt a problem. I think it's easier for you guys if you were just to multiply it out and then flip it later. So I'm going to do the example that the book gives the way that I would do it. And I think it would be easier for you if you did it that way. So let's take a look-see. We have 2, I'm going to say it's raised to the first power, x to the 6 over y to the 4th. And it's all being raised to the negative third. I wouldn't flip these at all, and I wouldn't change the sign. I would actually multiply this through. Negative 3 times 1, negative 3 times 6, negative 3 times 4, which gives me 2 to the negative 3 x to the negative 18 over y to the negative 12. Now that everything is negative, I can flip them. In your mind, you already know that these are simplified, and I can flip them. So the y to the negative 12 goes to the top, and the sign goes away. The 2 to the negative 3, 2 times 2 times 2 is 8, but it goes down to the bottom. So this is going to be 8. And then the 18 to the negative 18, x to the negative 18, again, goes to the bottom, and the negative sign goes away. So it's really a matter of when you decide to flip it. I flip it at the end. The book is flipping it in the beginning and then taking the sign away, and that can be confusing. I would multiply the negative exponent through, make all my exponents negative, and then flip it at the end because it's sort of easier to see that way. So I would recommend this method. If you want to do it the book ways too, that's perfectly fine, but I think that's a little confusing. So got it for we have a, I'm going to say it's raised to the first power. 5, again raised to the first power, b raised to the first power. And I'm multiplying it times -2. So -2 times 1 times 1 times 1. So that's a to the -2 over 5 to the -2, b to the -2. Again, since this is negative, this guy is going in the denominator, and it's being squared. This guy is going in the numerator, it's being squared. This guy is going in the numerator, and it's being squared. 5 squared is 25, so 25b squared over a squared. Voila. Okay, so that's 7, 3 and 7, 4. You guys have an excellent rest of your day.